In this video, we're going to build a fully meshed hub and spoke VPN topology using adVPN. We're going to see the hub and spoke topology also become a spoke to spoke topology without initially creating a VPN tunnel manually. So the tunnel between the spokes are going to be created on demand whenever communication needs to happen between these two. Let's get started on FortiGate 1 to build our adVPN. Let's see if we can reach FortiGate 2 and FortiGate 3. Exec ping 172.16.22.1, that's FortiGate 2, and FortiGate 3 will be 33.1. So our underlay infrastructure is in place, everything can reach everything. Now on FortiGate 1, let's build our VPN. This VPN tunnel here, I'm just going to call this hub, and to build adVPN on the hub, you need to select dial-up user and associate that with your WAN interface. I'll start off deselecting everything and only selecting the elements that we need. On the hub, the only thing that we need is essentially the auto discovery sender. Everything else remains deselected, meaning including device creation, which is your net device. It's disabled. Our appreciate key would be Fortinet. We will use IKE version 2 and will allow any peer ID. This will be good enough for our lab. And for our authentication proposal, I'll just select AES256 GCM and then leave the development groups the way they are. With the phase 2 selectors, we'll use all local networks and all remote networks. That is actually a requirement. Our VPN is created. Now let's give it an IP address. It's hanging off WAN interface, and our VPN tunnel interface is going to be 10.160.10.1. 10.160.10.1, 10.160.10. Let's say .253, or could be .254, or whatever, any IP address in the subnet that's not utilized. Enable ping on this interface. Now that we have our VPN, we have our IP address on the tunnel interface, layer 3 interface. Let's create the security policy to allow the VPN traffic. And because we're actually only interested in the spoke-to-spoke traffic, I'm just going to create a single security policy allowing spoke-to-spoke traffic, and I'll actually call this spoke-to-spoke, where the hub interface is going to be the ingress and egress interface. We don't want to use net in our network at the moment. If it turns out we need further security policies, I'll come back to this. But for now, I think I'm happy. Now, while we're at this, we might as well just do our routing. We said that we're going to use BGP to propagate our prefixes between our sites. So we enable BGP. The local AS, which is going to be the same as the remote AS, will be 65500, for instance, and our router ID, I'll just use 1.1.1. And because here we will have multiple remote sites, and because we don't want to create single entries for each neighbor, we want for this to be truly dynamic, we're going to use define neighbor groups. And our neighbor group will be, say, adVPN, and the remote group AS will be the same as ours, 65500, meaning every device that is in this group, every neighbor that's going to be defined in this group will have this as their remote AS, making this iBGP. Now we need to define a range, and the range is going to be in the 10.160.10 subnet /24. Now we attach this to the adVPN group, the neighbor group that we created. That looks good to me. And the local network that we want to advertise from the perspective of FortiGate 1, that's 10.10.10/32. That looks okay. I'm going to go into CLI and just validate our config for a moment. Show VPN IPsec phase 1 interface hub. What we want to see here is our IKE version 2, peer type any. The net device, like we said, is disabled. Add route, we disable this because we're using BGP. And the most important thing that makes this a dynamic VPN and auto discovery sender has to be enabled. And I think that's about it for the phase 1 interface. Let's now have a look at our BGP. Show router BGP. And here we've defined our neighbor group with the remote AS of 6550. The most important thing about this is that FortiGate 3 is going to be advertising its local networks to the hub FortiGate. The other FortiGate 2 will be doing the same thing, but the spokes need to learn of each other's networks. And imagine if you have more than two, if you have a big network, the hub needs to be able to receive routes and propagate the routes to the rest of the WAN. So we need to make the route, the FortiGate 1, a route reflector. So that means every neighbor would essentially be a route reflector client. That's what we need to enable. So we go back to neighbor group and edit our group adVPN and then enable a route reflector client. Now let's have a look at it. Let's have a look at it again. This config looks okay to me. I'm happy with it. So now we can move on to FortiGate 2. So from FortiGate 2, I'm going to test reachability as well, just for the sake of completeness. We have reachability as well, so we can go ahead and proceed with our VPN connection. I'm just going to call this tunnel 0, and we're putting it as a custom config. And here the type of remote gateway would be static because we know what the FortiGate 1 IP address is. That is 172.16.11.1. We associate that with our WAN interface. I'll start off disabling everything and then only pick the things that I need. And what we need to enable here is the auto discovery receiver. And because we're using BGP, we want to have the net device creation to be set to enable for the spokes. It's disabled on the hub, but enabled on the spokes. Our appreciate key has to match, and the proposal as well. We're done with our tunnel. Now let's give it an IP address at layer 3. We go to network interfaces, find our VPN tunnel, and give it an IP address. If we look in the topology, FortiGate 2 is going to be 10.160.10.2. And the remote IP is 10.160.10.1. This is the IP address of FortiGate 1, the VPN interface /24. All right, the next thing is the security policy. Here, I'll just keep things straightforward and create two security policies for inbound and outbound traffic. Tunnel in, so the ingress interface would be our tunnel interface. Egress would be our LAN interface. All right, next I'll clone this in reverse and call it tunnel out. So now we have two policies. All right. Now that we have our VPN, we have our IP address on the VPN interface. Let's see, did I enable ICMP on this interface? Yes, I did. The next thing is our routing. We go to network, BGP. Our local AS is 65500. Our router ID is 2.2.2. Here we will define a neighbor because it's only a single neighbor, FortiGate 1. And we use the VPN interface addresses 10.160.10.1. This is our neighbor, and 65500. That's the remote AS of FortiGate 1. And I'm going to enable software configuration. I think I didn't enable it on FortiGate 1, but no matter, I'll get back to it if I need to. It's always good practice to enable it though. And then the network that I'm going to advertise is 20.20.20.20/32. It looks like our config is saved correctly. Now let's just do some validations. Show VPN IPsec phase 1 interface tunnel 0. What we want to see is net device is enabled, add route is disabled because we're using BGP, and auto discovery receiver is enabled. Show router BGP, our local AS 6550, our neighbor with the same remote AS as our local AS, and the networks that we want to advertise. This looks good to me. I think we should proceed to FortiGate 3. Testing reachability to FortiGate 1 and to FortiGate 2, just for the sake of completeness. And now we're ready to set up our VPN. I'll call it tunnel 0. The IP address of the underlay infrastructure for FortiGate 1 associated to our WAN interface. Here I'm going to enable auto discovery receiver as well as net device enable. And let's not forget to enable auto negotiate. Now let's give our VPN an IP address at layer 3. FortiGate 3 is going to be 10.160.10.3. And our remote IP, that's the IP address of FortiGate 1, that's 10.160.10.1. We enable ping, and our routing, our interfaces have IP addresses. Now let's handle our routing protocol, BGP. 65500 with our router ID 3.3.3.3. Our remote PS 10.160.10.1. And we want to advertise to our neighbor the local address 30.30.30.30/32. Now time to validate our config, starting with our IPsec. Show VPN IPsec phase 1 interface tunnel 0. And we're seeing pretty much what we expect to see. Show router BGP. And we can see that our BGP config is in place. Everything looks good. Now, while we're on FortiGate 3, let's not forget to create our security policy. I don't think we created security policy for this one. Nope, we didn't. So we'll create our security policy tunnel in with the tunnel interface as our inbound interface, LAN interface as egress, outgoing interface, the source, destination, we disable net, and clone in reverse, and call this outbound, tunnel outbound. Let's not forget to enable this policy. And because everything turns green, we already know that our VPN is up. So while we're on FortiGate 3, let's check our VPN connections. We do have our VPN up, and it's in the up state, and the RX and TX metrics show that we have counters there. So exec ping 10.160.10.1. That's working, so it looks like our VPN is up. Now let's check if our BGP has converged. Get router info, BGP summary. So it says that we have a neighbor 10.160.10.1 which we manually defined, and we're receiving 2 prefixes from this neighbor. Let's check what those 2 prefixes are. So we're learning networks 10.10.10 advertised by 10.160.10.1 and 20.20 advertised by 10.2, which we know to be FortiGate 2. Now let's try to ping 20.20 and see what happens. We have a single tunnel for the moment. Exec ping 20.20.20.20, and we have a response. And now let's run this command again to check our VPN tunnels. And now we have a dynamic tunnel, a new dynamic tunnel created between us and FortiGate 2. Let's put on OSPF on top of this adVPN, because some people might be using BGP, but some people might prefer OSPF. And to do that, we'll start with FortiGate 1. So we'll go to OSPF this time, and then our router ID will stay the same. So this would be 1.1.1.1, and we'll just define, we're going to keep everything in area 0. We're not going to do multi-area OSPF or anything like that. And the networks that we're going to advertise into our area 0 would be the 10.160.10.0/24. In fact, I'll copy this because I'm going to use it a lot. And then the other network that we want to advertise for FortiGate 1, it would be 10.10.10.10/32. The OSPF interface the interface that will participate in OSPF, we'll just call this a hub, and then we select the hub interface. This is the interface that's going to be speaking OSPF, and that looks good to me. I will leave it at that. And then moving on to FortiGate 2, our router ID is going to be 2.2.2. Too many twos. And our area is area 0. Our networks into area 0 would be 10.160.10, and our local network that we want to advertise, which is 20.20. And our associated interface this is good enough for me for now. Moving on to FortiGate 3, we select OSPF 3.3.3.3, area 0. We advertise 10.160.10 network, as well as the local network that is hanging off FortiGate 3, 30.30.30/32. Tunnel 0 is the interface that is participating in OSPF, and we click on OK. And then let's look at our neighborships. Get router info, OSPF neighbor. Doesn't look like we have neighbors just yet. Show router OSPF. And that is strange. Let's try again. Show router OSPF. Get router info, OSPF neighbor. Oh, and now we have our neighborships. We can see here now that we have a fully converged OSPF pairing with FortiGate 2, but FortiGate 1 is in the init state. While that's happening, let's have a look at FortiGate 2. Get router info, OSPF neighbor. So for FortiGate 2, it has fully converged with FortiGate 3, but it's in the X start with FortiGate 1. And now it's in full state. If we refresh, we see it's in X start. It's in full, so it's flapping between full and X start. So that means it's unstable. there's two things that we need to remember. Let's have a look at this. So because we know that our OSPF interface is our tunnel interface, let's have a look at what our tunnel interface looks like as far as OSPF is concerned. Get router info, OSPF interface. And we're looking at the tunnel interface. So tunnel interface is a point-to-point, and on the spokes we have net device enabled, and this is point-to-point, meaning there can be only one or two OSPF speakers on this network segment. The problem with FortiGate 1 is that the net device has been disabled, and that's why the network is flapping between xstart and full, xstart and full. So what we need to do is go back to FortiGate 1 and make the tunnel interface to be to enable the net device. And for that, I'm going to go to VPN IPsec tunnels, and when you change this, of course it's going to break BGP, and I mean it is a fact that you won't run BGP and OSPF at the same time. And now we can see FortiGate 3 is coming up. It's in the xstart state. And now just like that, it's fully converged. All right, OSPF is stable. Both FortiGate 2 and FortiGate 3 are in the full state. And now let's check our OSPF route table, or rather our route table. Get router info, routing table, all. And we can see that apart from the directly connected and the static route, we have OSPF routes. So OSPF has administrative distance of 110, which is far more preferred than the IBGP metric of 200. So, but if we do, BGP is still lingering around in the background somewhere. Get router info, routing table, database. We can see that we have OSPF and we have BGP. So if you look at the prefix 20.20, we do learn it via BGP, but we also learn it via OSPF. And the OSPF metric has an asterisk and greater than sign, whereas the BGP doesn't. But I believe this brings us to the end of this video. Thank you for watching. I'll catch you in the next one.